Welcome everybody to Everyday Asphalt. My name is Jim Warren. Welcome, and we're glad to have you guys here today. The Everyday Asphalt is a program that we have started this year that looks at four main areas. It looks at materials, design, construction, and maintenance. So every month we do a little bit different subject, and wanted to remind you guys that all these programs are aired or that are placed on our YouTube website. If you go to YouTube, type in Texas Asphalt Pavement Association, this will come up, and we have a featured playlist here for Everyday Asphalt. All our programs here for the whole year are placed in this section. What we'd like you to do is like, subscribe, and share, so then you'll be notified when these programs are put up there. So not only do we do them online for third Thursday of the month at 3, but then we put them up here so you have access to them later on. So we're glad to have you guys here today. Let's go ahead and get into it. Today's speaker, or today's guest today, is Robert Trevino. Robert, come on in here. Robert is a regional services specialist with Terracon, used to be with TxDOT for quite a while. And so Robert, welcome to the Everyday Asphalt.
Thank you. Appreciate the opportunity to be here.
You doing well?
Doing good.
Awesome, awesome. So today we're going to talk about maintenance a little bit, and we're going to talk about pavement forensics, kind of 101, as part of the program today. So let's just jump into it. So what are we going to talk about?
Thanks, Jim. So, well, for pavement forensics 101, I have a few items on the agenda.
Yep.
The first thing I want to talk about, because anytime there's a payment distress or you get asked to go do a forensics, if it's
which
a
is part of
payment,
what you do.
Yes, sir.
Yeah. Okay.
You see a distress in the payment. It's easy for people to point out the hot mix, right?
All right.
But we really need
because it's at the surface.
It's at the surface.
Yeah.
So we need to talk about a little bit about the different payment distresses, and then we can talk about the payment forensics process.
Mm-hmm.
I'm going to bring up a brief case study.
Yep.
And then at the end we can talk about the repair considerations.
Awesome. Awesome.
Let's get started.
So one of the things that we talk about in the Engineer Asphalt Essentials course is we talk about this idea of determining what a symptom is, what the cause is, and what the solution is. And Robert, in going through this, is going to basically kind of mirror the same thing. Is what you see may not be what the actual issue is.
Correct.
It's just a symptom of what the issue. We want to get down to the root cause, and then our solution is going to work on the cause of that problem, right? So you brought some slides along, and so we've got a photo here of a crack in a shoulder.
Yeah, so what we have here on the screen is a longitudinal crack.
Mm-hmm.
One thing I like to talk about is sometimes it is structural related,
Yep.
Sometimes it's a load related, and sometimes it's environmental related. Sometimes it could be a volume change.
Right.
So in this case, for example, you got, we don't know, right, until we go out there, put some boots in the ground, but you got the longitudinal crack,
right.
And then you look at the ditch. In this case, you got some water ponding there.
Back up here.
And so what happens is when you have, high PI, you get some water in there, and then that edge starts moving,
yeah,
right?
And the water
Shrinks
goes
and
out,
swell, and you got
that
that crack,
and
right?
all of a sudden starts to break off along that line there.
That's right. And then sometimes, as I mentioned, it could be, volume change. It could be a construction joint.
Mm-hmm.
And as you mentioned earlier, sometimes, we're trying to look for that smoking gun. Sometimes there's several reasons. Many times it's just several reasons.
And to me, I think the key thing there is list them all out. List
Yes.
what you think could all be the issues. And then you start kicking stuff out, and then you start looking at interactions. Well, if this happened, this could happen.
Yes.
And if my water was getting into the base, well, then that could happen as well. And so I think as you start to define that out, but you got to start everything. And one of the things I always look at, I'm going to start from right away to right away,
Mm-hmm.
and look at everything that potentially could contribute to the issue. Whether I think it's an issue or not, I want to make a note
Mm-hmm.
of it. And then if I'm actually out here on boots on the ground, or if I'm just looking at a photo, like we are right now, I always look at the ditch because I'm always looking. It seems like we seem to like a lot of times we have a drainage. Not that we've had any water in Texas for the last month. Maybe someday we'll get some, but I think when we get some, then we're probably going to see some big issues.
True.
Because right now we got everything drying out. But what happens when everything gets wet again?
Yeah.
You're
starts
going to be
moving
really
around.
busy. All right, you got another photo here.
Another picture here. And
Stop bar, that means we're at an intersection.
we're at an intersection. And the problem here from the picture alone is just rutting.
We've got some But we've got different kinds of rutting, right?
Mainly, you know, we have a couple rutting issues. One of them could be a mix issue, but also can be subgrade rutting, right? You got two components.
Right.
Have to identify if it's a mixture or if it's a subgrade issue, but there's two, right? And then the shape of it, right?
Yeah.
You want to talk about?
Yeah, that subgrade rutting typically is kind of like a valley or
wider.
a swale. It's wider, narrower, or wider. And when you've got mixture deformation, or where the mix is becoming, I wasn't going to use the word plastic, for any number of reasons, that mix is literally just kind of moving at the surface, and it's very a superficial thing, and that's a little easier to fix than you've got something that's got a base, and you got rutting in the base, right? So those are, but again, they're both called rutting, but they're different failure mechanisms.
Yes. Yeah.
So we have the same issue with cracking when we start talking about cracking.
Different types, you know, different ways to identify and different repair methods for each one.
And, you know, and when you get kind of this base rutting in here, again, looking where it is, obviously in intersections, you've got slow moving traffic, you've got stopping, you got, you know, a lot of shear stresses in these slow moving areas. You know, when you get down to it, obviously, if it's a base type failure, that's one thing. If it's a mixture type failure, well, maybe, you know, we could change the binder type when we repair it. We go to a higher binder, use a, you know, PG 70 or 7622 in those areas, which would make that mix a little stiffer.
Maybe a different mixture as well, more stone on stone.
Yeah, go from a dense graded to a super pave, or maybe even an SMA in some cases, where you can kind of work your way up the ladder. Again, you've got a lot of options in the asphalt world out there, and we just want to put the right thing in the right place. So yeah, intersections are something we need to look at as well. Ooh, this looks like my former days in Florida with the alligators. We've got an alligator crack. Pretty bad alligator cracking. We don't like to show bad pictures, but stuff happens.
Talk about it, right?
Yeah, we talk about it.
Alligator cracking, usually load related, right?
Yep.
You got some load related issues. It could be that. And sometimes, you know, you can build a perfect pavement design for the traffic you have now, but that traffic picks up, and now that structure is not enough for those easels, right?
We're seeing that all over Texas, right? I mean, you've been all over, you've seen it all over. We've got 1,000 people moving or 1,100 people moving to Texas every day. We've got all the ancillary supported stuff associated with that. We got a lot of these what were lower volume roads at one point. Now they're higher volume roads. You know, they're maybe energy sector roads, and you said you do a lot of work down south. You're seeing a lot of just the commerce coming across the border.
Yeah,
and
border
you look
crossings.
at I-35, you look how much of that is truck traffic now coming northbound and all that. So we got all that stuff to deal with as well, and so we've got to upgrade our pavements to try to carry the load, and not even really knowing where we're going to be in 5 years. You know,
it's hard to predict.
5%, 10%, 20% more. So these are things we've got to start thinking about now. But obviously we've got an area in here. When you have a load-related fatigue, or when you've got a load-related problem like this, it could be, again, there could be a number of symptoms. It is load-related, but is it because there wasn't enough structure? You know, obviously that could be one. Could it be the wrong binder? Could it be wrong mix not thick enough? Could the mix be aged greatly, and that's going to decrease the amount of give that mix is going to have. So there's a number of issues here, but this is not going to be solved with just, you know, 1-inch overlay on top of it.
This is something we really have to diagnose.
Yeah.
We have to determine, okay, is it the hot mix, the base, the subgrade, or a combination, right? It could be several things, right?
Absolutely. All right, so we've got, you know, rutting, cracking, fatigue is a cracking mode as well, but these are primary distresses, right? And we have more cracking in the state than we do rutting, and so I mean rutting can be a problematic from a safety perspective if we have deep ruts and if it ever rains again.
Sure.
And we get hydroplaning and that sort of stuff, but cracking we can kind of live with, but it's indicative that there's a problem in the pavement, and it doesn't get any better. So we want to try to resolve it and look at it. This is another picture of, looks like a slip. This is a classic slippage failure, where you've got a bond problem.
Yeah, you know, when we talk pavement structural design, we need to make sure that that you have a pavement acting as a structure, right? So you need to make sure that all the pavement layers are bonded to each other. So it's important with tackle, right? We want to make sure it's there to make sure that not only the hot mix is sticking to the base, but also that there's bond between layers, so we don't have an issue like this one.
Absolutely, absolutely. And that's a big deal. I mean, we're looking at TxDOT is looking at a shear bond strength test.
Okay.
Trying to evaluate that to figure out if there's actually actually take a core through the pavement and then they shear it right at the interface and they measure the strength of that interface. They're still trying to figure out what that number needs to be. But we know that there's very high shear stresses just a couple inches down. And if we put that very high shear stress right at an interface, well, and if we don't do a good job with that interface, well then potentially now that pavement is not acting as one, it's acting as like this, and
independent layers, right?
Independent layers, and they're not going to be near as strong as if the whole thing was acting as one.
Yes.
So show me here what we got here.
So this one, I wanted to bring up this picture because there's a couple of things, right? So in general, this is stripping, but if you look at over here, originally there was a crack. Right, and
right through here,
right there,
okay.
and then it was sealed. You can see a seal coat right there, but there's a couple of things, right? First of all, we need to be proactive with maintenance, right? As soon as we see a crack, seal it as soon as you can, because then you get water in there, and then you see the stripping issue right here. Once you get water into your pavement, it can cause all kinds of damage. It could be in your hot mix. If it goes deeper, it can be in the base or the subgrade, right?
Sure, absolutely.
And then the next thing I want to talk about is once we get to that time where we have to do something about it, in this case, say you got your schedule 2-inch mill and fill, and over here, you can see if you do your 2-inch mill and fill at that point, where are we placing that overlay on top of, right?
The failed section right here. We really need to be probably down here somewhere.
Yes, you're right.
To resolve that issue. So again, what may be in the book as kind of SOP, standard operating procedure, we still need to go out and put eyes on this and cut some holes and take a look and see what's going on. And if the issue is deeper than what the book says,
yes,
or the standard practice is, we got to think about this, because by just taking off this 2 inches and putting 2 inches back, it's going to fail in a very short period of time. And now we've wasted even more money, more resources.
Yeah, that next scheduled overlay, instead of being 8 years, 10 years from now, it's going to be soon.
3, yeah, it's
too
going to
soon,
fail
right?
way too soon. So again, I think the idea behind this program here today is we want to get out. I mean, you've mentioned looking at stuff, and you'll talk about looking at stuff kind of from a Google perspective, but really going out and looking at the pavement. And it don't hurt to punch some holes in the ground.
Right.
At least a couple to see where we're looking at. We're going to talk more about that here in a second. But really try to understand what the problem is. I mean, we've seen that in some other areas where the fix is here, but the problem is here. And so they fix it, and guess what? The problem comes right back. And then, it's like definition of insanity, doing something over and over and expecting a different result, when the reality of it is it's actually down here. We need to, if we're going to fix it, we got to fix it right. And obviously and the longer we wait, it's not going to get any better.
Right.
So it just ends up becoming a challenge here. So, and I think in the case here, if you've already got water infiltration in here and then you seal it, now you're just kind of sealing that water in. And now you put, 32 days of 100+ degrees or whatever it is, you create steam, and then that steam is a great example to create stripping.
Yes.
So again, if we don't have drainage, we don't have proper drainage for the pavement, and if we're not watching where the water's coming from and given it positive drainage, we can end up having a pretty significant issue.
Correct.
Yeah, so good picture. All right, so let's go through the process.
Okay, let's talk about the pavement forensics process. The 3 steps, and as you mentioned earlier, we need to diagnose. But first, starting with the review, there's 3 things we like to look at. The first thing is, let's look, is there a pavement design, an original pavement design, and an original traffic projection? Then any available plan specifications and typical sections, right? So if we have X number of inches of base, X number of inches of hot mix, we need to know that information before we go out there and validate what is out there. And then any available bore lock soil maps, we need to make sure we know what we're sitting on top of, right?
Sure.
We have clay versus a silt versus whatever we have, sand, right? Yeah. We need to know what are we sitting on top of so you can do.
So if you know what's supposed to be there,
yes,
and then you go out and you do some investigation, you can evaluate. You know, here's what it was supposed to be, and here's what's actual.
Yes.
And you go, what if they're not? Well, then that's going to give you an indication of maybe that's why you're out there.
Yes, yeah, that you're exactly right. Validate. We're after validating, right? This is what we have. What do we actually have?
And I think the one other thing here that I'm glad you brought up is and we mentioned it already, of just looking at the traffic loading. You know, what was that original pavement design? What was a 20-year design? Was it 3 million, 8 million, 10 million, 20 million? We're seeing pavements now that have got 40, 60, 80 million or 100 million each of roads now. And so what's happened to that roadway in the last 10, 15, 20, 30 years? Mm-hmm. And have we just wore out? Mm-hmm. Have we just wore it out? We were joking earlier about it gets stressed. When eventually it gets too stressed, eventually may just crack, because it's just not designed to carry that level of load anymore. I look in the area around here, the amount of traffic increase all over the state. It's a challenge. Mm-hmm. We gotta be realists about it. I mean, you do a lot of work down south. We look at how much material is coming across the border, how much northbound traffic that is. Every one of those truckloads is loaded, mm-hmm. and and then it's all getting distributed across the state as it goes to different areas. It may go north, southwest, it may go west or east, but it's all getting distributed across a lot of the roads that we've got. And so it's not just I-35 or I-10 or 65 or whatever it is. It's people are finding other ways of moving around.
Yeah.
And so it can be, we've got a pavement that was in good shape. All of a sudden it's not. Well, if you Google Earth it, you won't see all the truck traffic. But if you go out and park for 20 minutes and have a cup of coffee and you go truck, oh, well, maybe something's happened.
Yeah, and you bring up a good point. Google Earth, that's something we also like to use. Mm-hmm. Traffic is very hard to predict, right? We don't know what's going to happen next year, next 5 years. But, one tool we like to use is go to Google Earth, look at the satellite view, and then go a couple of years back, maybe 5 years back, and see is there any new developments, right?
Earth?
Yes.
Okay.
You get that options, go a few years back. Maybe right now, we've seen the stress recently. There's mm-hmm. a new development, or energy sector, or whatever, right? So that's another tool we can use before we go out there and verify. Okay, that development is bringing this much more trucks, right?
Okay. So just by, I guess I've not done it, but apparently there's a little toggle in Google Earth. You can kind of go back and forth. Yeah, I mean, if you go, this was a field, and now it's a, urban area. Well, yeah, obviously. That's a great idea. Again, use all those tools that are available, that are out there. So then you're going to go out on the site. Yeah. Now
that we have an idea of what we're dealing with, let's put some boots on the ground. Okay. And you mentioned earlier, right? Let's look right away and see if there's you make up your list and start writing all the possible causes, mm-hmm. and then based on that, you diagnose the problem. Okay, I got the distress. I know. Approximately, I could tell maybe this is the cost, and then you go back to the drawing board and then use your available tools to go out there and validate. So you need to diagnose the problem, targeting the cost, so you know how to fix it. Good.
Yeah, perfect. That makes perfect sense. I mean, it's not a one size fit all, right? Well, the book says I got to do this. Well, it may not be that at all. Mm-hmm. If it says 2-inch mill and fill, you may need 4, you may need 1. Or you may just need an overlay.
Just an overlay, that's right.
Just depending on what's going on and how well that pavement was constructed. So, mm-hmm. and we're getting better quality with our mixes every year, but we still got challenges moving ahead. So we got FWD here. Explain how this works.
Yeah, so when we talk about the pavement forensics process, we have many available tools. There's a few I like to use. One of them is FWD. Okay. So what you have is a trailer, fallen weight deflectometer. Okay. You have a load. It's a 9,000 pound load.
That's right, going right back underneath
right there. And you have a set of sensors that are going to be sitting directly on top of the pavement. You pick up the load, drop it, and then you measure that pavement response. So that just a quick indicator. W1, the first sensor gives you an idea
This one here?
it's directly under right there. Yes,
okay,
so right
the
there,
sensor.
it gives you an indication of overall stiffness of that pavement.
Okay.
So that sensor alone, you can see consistency, and then when it goes up, something's going on. Maybe that's the place where I need to look. Is there distress? Okay, what's happening there?
And this
It's
is
a quick
fast.
indicator. It's fast. You drop maybe a minute per drop,
Okay.
drop it, and then you can do a number of drops over the pavement, and then you can go back and review. Okay, now I have an idea of what the pavement is
Maybe I
doing.
need to narrow down in this particular section.
Yes, sometimes you can say, okay, 80% of the roadway is fine, but I have a few sections where I need to look and see what the problem is, and maybe a different, because it could be that you have two different types of repairs for that same roadway.
And that's where you're going to get into your next steps.
And then I'll get into the next step.
Okay, which is
Dynamic cone. Dynamic
Okay.
cone penetrometer. So now that you evaluate the roadway with the FWD, maybe you pick a control section where you know there's no distress, the deflection is what you expect, and then you see another location where you have a little bit of distress, the deflection goes up, and then you use this tool, right? In this case, we like to drill a core and see how much hot mix we have. You know, it's wet coring, so you wouldn't want moisture to affect the base, so we go a few inches and then drill an access hole to the top of the base and
Okay.
run DCP,
Okay.
and then we
You
can
just
get a
drop it down
stiffness.
in the hole and then start the process from the
the top of-
subgrade, but you've not damaged it
with
in
the
process.
moisture.
You just take a shop vac and suck all the dirt out of it, or
Yeah,
something like
so,
that.
so with the hammer drill, I mean, just drill the hole,
Okay.
and then right there we start
Okay.
measuring
start-
start
okay.
running the DCP on top of the
Okay.
base, and then we start measuring the stiffness profile of the base and the subgrade. You can estimate the base thickness,
Okay.
and then if there's a stabilized layer, sometimes you see that stiffness profile change
And again, a pretty quick test.
very quickly.
It
Yes.
probably takes longer to drill a hole than it does probably to run the test.
Yeah, if
There's
it's
no
very
doubt.
stiff, then it'll take a minute, but if it's soft, it'll go pretty quick.
Pretty quick. Okay, very good. So we got the FWD, the dynamic cone the DCP,
Mhm.
okay? And then we got good old coring.
Coring,
Yeah.
easy one, right?
We're going to burn a hole in the pavement and see what it looks like.
See what it
It's
looks
gonna
like.
it's going to give us a sample of the mix. And again, you showed that one core that had the stripping. It was very evident that there was a problem in that situation.
Mhm.
But then we've got, what are we doing here? Are you looking at the crack? Are you crack mapping in this?
Yeah,
Okay.
we usually like to, okay, once we drill or control, now we move on to a section like this where you have the stress, drill it, and then log. Okay, I have inches of hot mix, it's this much thick, and then does the crack go through the hot mix, and we make our notes and then document it with the picture.
Gotcha. Well, looks good. So then when you get back, then you've got all this stuff to look at.
Yeah, now we know the tools, and TxDOT, when they do payment design, they go off of, of course, the TxDOT payment manual, and there's
You'll do a little bit about that.
a little bit, and there's design values, or typical design modulus values for each of the layers, right? Starting from the ground up, your subgrade should be between 8 to 20 KSI. Sometimes is weaker than that, and then if you have a stabilized layer, that range is 30 to 45. Usually, if there's no stabilized layer and you have flex space on top of the subgrade, then that flex space is going to be affected by the subgrade, right? If you have a weak subgrade, your base may not be as
Not be
stiff.
as strong.
Right?
You can't use as strong a number.
Right. So
Okay.
usually that range is between 3 to 4 your subgrade modulus,
Okay.
the flex
flexible
space.
base.
Yeah,
Okay. So if your modulus is 10 KSI,
could
then
be
you
30
do
to 40.
40. Okay, in that
Correct.
range.
Yes,
Okay,
sir.
that makes sense. And then obviously, this is all mix dependent.
Yes.
And different mixes have got different modulus.
Yes.
And so, and then you've got what's in the pavement manual, and the super pave is stronger than the dense graded,
Mm-hmm.
and SMA and super pave use the same set of moduluses.
Yes.
Right. And as the thickness of the layer goes up, you actually can increase modulus because it's now working kind of like what you're talking about down here. It's all working together a little bit better. So,
Mhm.
but again, and then you've got local districts got their own SOPs,
Yes.
standard operating practices, so they may modify this as well a little bit in their areas.
Yeah,
So-
based on what they have, right?
Yeah.
You have some districts that are sitting on better soil, some weaker soil, so they know once they build the projects, they go out there with the FWD and then start building that database.
Okay.
And same with the hot mix. Okay, they validate. Okay, I can actually get 650 or 750 or 850, and they know what they need to do for
Gotcha.
their
So you
specific
being
area.
a consultant, if you're working in Austin or you work down in FAR, okay, you got to make sure you check the local SOP
Yes.
as well when you're putting your designs together. Make sure they're kind of in concert
Within
what
range.
they want
Yes.
locally.
Yes, that's the thing we do. Yeah, we
Okay.
talk to the districts.
Good deal. All right, so walk me through here.
Okay, so one of the things now that we've talked about, FWD as a tool and typical values that we use for design, there's a tool in FPS. It's the stress analysis tool. So what we can do with this tool is you get essentially a typical section. You say, okay, my subgrade is 8 KSI, then you got a lime treated layer, a flexible base, and a hot mix. And once you assign the thickness and the modulus value, then you can simulate what that deflection bowl is going to be, right? For this particular section, that deflection is approximately 17 mils. Okay. So it's just a quick indicator, okay? If I have a pavement that the plans say it's this thick, I do the simulation, okay, I'm going to expect 17 mils. So once you go out there, run FWD, then you can see that consistency, okay, it's 17, 18, but when it doubles, right?
Yeah, you're going, you want 17 and you're getting 40.
You're getting 40, then what's going on, right?
Yeah, oops.
Or sometimes it's slower. Maybe we run into a full hot mix layer. Now that deflection is slower, but you got to look for certain things, not only what you expect, but the low and the high deflection, and then that's how you can, at a target different range to see what's going on.
Sure, that makes sense. That makes sense to you guys? Hopefully. So then you could go back then and, obviously if one of these was significantly different, or if you do some additional work, you go find out that, hey, that layer wasn't 5 inches thick.
Yes, that's a great point. And you can do that simulation
and you go out
as
there
well.
And, hey, it was actually 7 inches thick or 4 inches thick. You go, well, that should change this deflection, right? So then, I think the way I look at it, there ought to be a reason for the number. Right. I mean, there ought to be some. The science ought to tell you. If you can evaluate those different lifts and the different materials and that, it ought to make sense. And if it doesn't make sense, then maybe one of my assumptions is off.
Right.
Maybe they said, yeah, it's got 12 inches of flex space. Okay, I'm not going to take your word for it. And then you go out and you go, well, this doesn't make sense. You go out and there's 8 inches of flex space or something else like that, and you kind of go, well, okay, now
I see why.
Now I see why. Okay, that makes sense. So in FES 21, you got a stress analysis tool. Again, if you're not using it, it's out there. You can use it, and so you can go through and you can plug this in. And I know that I'm going to call you a pavement design geek, but with love. But I know the shape, even the shape of this curve makes a difference.
Yes.
In getting into the details in there. So, and so now we've got. This looks like we've got a pavement that you've actually done some testing on. This is your results.
Yes. So as we mentioned, right? We mentioned, okay, now that I expect this deflection, okay, I go out there, I set my control. I want to see what that looks like. And what you have right here is just an example of the way I like to plot that DCP. So I plot it in layers, starting right here. That's the bottom of the hot mix, or top of the base.
About 7 inches of asphalt.
7 inches of asphalt.
And now we're testing below that.
Okay. You said the DCP start dropping the hammer and start measuring that stiffness profile, and then you see a change right there. Okay. That's when you hit your stabilized subgrade layer, and then right here, that's where you hit that natural subgrade. Okay. So for this one, there's formulas in the pavement design manual.
Boom, 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 and then go like that, and then you're kind of in a new layer, then boom, 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 and then it'll drop some more.
It'll drop.
And it'll tell you kind of, well, obviously you can measure thickness.
You can measure thickness as well.
Through that, and also measuring that strength of that material.
You estimate the stiffness,
so that helps
right?
line this up.
Yes. Okay. And sometimes, that's where you mentioned it earlier. So are we missing a layer? Are we missing thickness? This is a quick indicator of where the problem is. Sometimes, you do forensics on a cracked pavement. you get the moisture in there, and maybe it's just affecting the top of the base, so you don't need a full rehab, maybe, and the stiffness profile is going to show it, right? You may have a couple inches that are weak, but then you're sitting on solid base.
So I just got to get below that weak layer.
Yes, and then from then design up.
And
yes.
go and keep that.
Keep that
the bottom
if you can. Yes.
Okay, and then just rework. So it helps me isolate.
Yes.
How deep I need to go. Okay, that makes sense. That makes sense. So looks like we've got a little bit of rutting in the roadway, and we've got some cores. So
a little bit of rutting. So a quick tool, coring. Right now that we've talked FWD, talked about DCP coring. Sometimes coring, you can do it very quickly. It can give you a good indicator of where the problem is. In this case, we're assuming that it was in the surface layer. So what we did is we drilled a few cores, focusing on the wheel pads, and then in between the wheel pads.
Okay. Here, in between, and then out, and then in the wheel path again.
And then we line them all up, and then we try to see, okay, can we isolate where that problem is? In this case, right here, we know the bottom of that surface layer is consistent, but then we see a little drop right here, right?
Okay.
So there's a little bit of consolidation or displacement down and then outside, right?
Okay.
So in this case it was a surface rutting issue.
Okay. So that we can fix by just removing this layer, and we'll count all this still good. So now we come in and we just mill that out, and we're good to go. The thing I like about this, Robert, is we've got a nice straight edge across here. We're spanning the whole lane width, so it's probably maybe at least a 10-foot straight edge. You can use a string line as well. They're also measuring slope. I love that. Okay, can this pavement drain?
Is it draining? Correct.
Is it draining? But then it gives me that artificial reference point, which is what you're showing here, and then I can physically measure down, knowing that where that surface is. So if I was going to cut a core right there, I can measure down. We're half inch below my line, and now I can actually see that. And then sometimes it's, it's not necessarily this is declining much, but sometimes it's kind of shoving up in that area. And so you got to, again, kind of look at the material. So this might be good, if we wanted to maybe analyze this mix a little bit to see if it might have too much asphalt in it, or maybe just a wrong mix or wrong binder, or those kinds of things that would maybe cause it to have more of that plastic flow. Okay, good idea. That's good, great slide, great slide. I love spanning the full width. I love measuring the slope. Big fan of that. But again, you look down here, you can see pretty much where those layers are all independently together.
They're together. So there's bond, and you can actually see some base sticking to the bottom of the hot mix. So there was bond even between the hot mix and the base.
And I think we can't underestimate that of how we want that whole thing to work as one big monolithic structure, not a bunch of independent layers. Okay. So it looks like we got a core hole here. We got two core holes. Okay.
A few more pictures on coring, just again to diagnose the issue. Your picture, the first one, you can see where the crack,
right here.
It's isolated within the hot mix layer, right? And then you can run a DCP and see, okay, how's my base? Is it stiff enough so that I can only, maybe the fix right there is just the replacement of the cracked hot mix layer, right?
So that helps then set the thickness. If I'm trying to get all the crack out, I'll just take out whatever that number is.
Whatever that number is. And then on the other side, sometimes, the problem is deeper.
So it's cracked through here, and it's actually the crack, it looks like it's going further down. Now we got bigger. Now we got more decisions to make.
Yes. Now we gotta diagnose. Is it in the base? Is it go down to the subgrade? Right. Try to make sure you isolate how deep that crack goes, and then lengthwise. From where to where, so I can focus. Okay, this section needs a rehab. But
we're using good science. We're using good values. We're not just going 2 inches. And or whatever it is. We're trying to fix the problem. Okay. Again, you got another slide here. Again, some more situations. This one is actually cracked through the entire multiple layers here. This one, nothing.
Right. So in this case, you kind of have you're right. Other than the stripping, right? So it's not cracked, but you see the first picture. You drill a core, you find the stripping. You want to make sure if you're going to schedule something for that project, how deep is my problem, right? Now that you look at the core pictures, you have the crack going through the strip layer, and then we drill the core in between the wheel pads where there's no crack, so we can get a full core, and then you can use that as a reference. Okay, my strip layer goes that deep, so even if I did a resurfacing, yeah, maybe I get rid of part of the crack, but then I'm sitting on stripping, right? So let's make sure we go deep enough to get rid of both the cracking and the stripping.
So just make sure everybody's up to speed. What's stripping to you?
Stripping when the asphalt loses its ability to bind to the aggregates in the mixture.
Okay, fair. Yeah. For some, it could a lot of time. Typically, moisture is one of the issues with stripping that we're trying to resolve with. So if we have those cracks and we don't seal those cracks, and water can get in, water can't get out, you get 30 days at 100 degrees. Can kind of start causing that material to heat up and to cause a problem in there. So again, challenges. Then you got another case study here.
Okay, brief case study here. We were asked to look at a section of pavement, and it was as you can see, there's a lot of longitudinal cracks in that pavement. And
this is just different parts of that pavement.
Different parts.
Okay.
Yeah. Right. Same roadway, same section. I guess different sections of that stretch, but it was isolated, and then once you moved out of that distressed area, everything looked fine. So we did some soil surveys, and the first thing that stands out is the PI of the subgrade within that area was higher than the rest. Right. So that's one.
Okay.
And then
the road was probably widened at one point in time, maybe, and they added another lane, and now they added so I'm just trying to figure out how that could happen.
Well, possibly. Yeah, sometimes it's just the soil. It could, you can have one project. Sometimes it's clay, silt. Just the nature of the subgrade. Sometimes it just varies throughout a stretch. I wish.
Hey, I always look when I see these kinds of pictures. I always look out here, and I see a shoulder, and I see water cannot get off this pavement. And so that to me is always a kind of a red flag to say, hey, and if I've got high PA clays down below, and I got water that can't get off the pavement into the ditch line, that means the water is going to go sit right in here, and go probably down if it can. Okay, if I stack enough water up there, okay, and so that would exaggerate, make it worse. The situation. Now I'm forcing water in and out. So again, watch your drainage. This is, it's probably it's certainly not sexy, but it's something we gotta keep an eye on. So let's keep going here.
So just we picked a couple of locations to core. We got core 1 that was outside of the distress. One of the things that we have, so if I move out, so right here you got the hot mix layer of core 1 inch. There's only an inch of asphalt and then 7 inches of base. Wow. Over 30 PI clay, and it's doing fine. But you move to the other one right here, there's 21 inches of mix, and it's cracked all the way down, no base, and it's sitting on 47, right? That's a PI of 47. So they just kept
stacking layer and layer, and it just kept sinking, and
yeah, and those maintenance forces are out there, frequently doing mill and fill level ups, and you don't really get to the issue, right? You need to fix the drainage.
Right. Right. Gotcha. Good. All right. So let's look at our considerations as we kind of wrap up here.
Yes, sir. So, as we discussed, you want to go out there, identify the costs. You need to make sure you identify the costs so that you know how to properly fix it. And then, take that, when we do forensics, it's always about lessons learned. So how do you prevent that in the future, right? We know that happened here. Okay, now we know, let's fix it. Don't do that in the future, or this is the way we mitigate that issue in the future. And again, going back to our original discussion, once you see something going on, it's easy to point at the hot mix. But is it in the hot mix? Is it in the base? Or is it in the subgrade? Right?
Gotcha. Drainage.
Critical.
Right.
So, couple of things that are critical, right? Your foundation. What are we sitting on top of? Is it clay? Is it rock? How stiff or how moisture susceptible it is? And then Now drainage, right? Are we keeping water out?
Yeah, yeah. And then we've got these other options.
Yeah, once that we
I think we've got another. I think we can illustrate it here with this slide here.
sure. Now that we know the problem, now we know, okay, let's put it in the drawing board and lay it out, right? Is it a hot mix issue? Is it a base issue? If it's a hot mix issue, and how deep do we need to mill,
Okay.
so that we address the problem? If it's deeper, can we do a full depth reclamation? And once we do that full depth reclamation, what is left, right? And what is this right here?
Okay.
Is there something stable that is going to act as good support for my fix? And then, you got other considerations. Maybe some districts that you can't raise the profile. You're right
stuck.
here, right? You're
can't
stuck.
Go any higher. Right.
So maybe you need to do a prim mill and do a repair and then go back to that same elevation. There's just many considerations. It's
Okay.
not as easy as let's do this, move on. You also got to think about traffic control, industry experience in that area, district standard operating procedures before you come up with a good solution.
I've seen situations where you're fixed here, but you got to beef the pavement up. So they actually take out some of the base and they come back and they put a higher type asphalt in there. So structurally, you end up with the same elevation, but the structure itself is stronger.
Yeah.
So there's another option there if you're kind of limited on, you got a bridge, bridges or overhead or some sort of thing, or you don't want to have to replace all the curb or some sort of situation in there as well. So, but again, I like what you're saying. Get it all plotted out, get it all lined out. Look at your local conditions, look at your local SOPs, talk to the local people that are working in that area. And figure out, particularly you, you move around, and we've got other consultants that do work in different parts of the state, and you really need to tie in what's happening locally to make sure that the designs are going to match in there. Just because it works in your district or where you're from doesn't mean it's going to work somewhere else.
Yeah, and we get all stuck to the contractors, right?
Yeah.
It's always good to have that discussion. Hey, is this something you can build?
Sure.
And
it's kind of important.
It's very important,
Yeah.
right? They're the ones that are going to be out there building your job, building what you design,
Yep.
and then at the same time, speed of construction. Sometimes it's okay, I can do a full depth reclamation, but what is my traffic going to do? Should I consider full depth hot mix?
Okay.
If I do consider full depth hot mix, what is the foundation, right? We looked at the case study that was sitting on clay, no drainage. But again, in this case, if you have a little bit of base or just enough that works in your pavement design, okay, maybe that's a place where I can do full depth hot mix, get in and out quicker.
So again, it's not a one size fit all. I
Yes.
think that to me is like the takeaway here is that there's
you're
not
correct.
a one size fit all with this stuff, and you got different, but you got to look and see what you've got. You can Google Earth. You can look at time. We talked about that time shift deal. Boots on the ground. Go out and see what you got out. Isolate. Find what's normal and find what's abnormal and test the abnormal stuff, and then bring it in and start weighing through your solutions and your options there. That makes a lot of sense. So we are about out of time. I look into the clock and I go, man, this has gone fast. It always does. Always great to have you in here.
Thank you, Jim.
So a lot of options here. Again, if you want Robert's information, let us know. We'll get you the information. But I'm sure Robert's got his information out there. Everybody knows Robert. So we're again glad to have him here today. We will see you next time on Everyday Asphalt. That'll be next month. Third Thursday of the month is kind of our standard time at 3 o'clock. Remember, if you missed this presentation or if you want to see any of them, if you go to the YouTube site, and if you want to have a watch party and bring everybody in and watch it, you can do that as well. If we can help you at all, please give us a holler. And that's one resource that if you want to know what contractors think in a certain area about certain, you want to try something, let us know. We can try to get you in touch with, whether you're in Laredo or Lubbock or, El Paso or Atlanta. We can try to help you out with that. So again, check us out on the YouTube site. Like, subscribe, and share. And that's about it for today. We're really glad to have everybody here today, and I appreciate you guys weighing in. And we will see you next time on Everyday Asphalt. Take care, everybody.